Alright, time for another draft science video presentation and such. Alright, starting at the beginning. Um, Human to human, probably isn't going to work. Alien, okay, through you human types. Um, what's the truth of our existence? What's the truth? How's the universe work? All of that kind of stuff. And it should be something you can explain. You shouldn't have to start talking about virtual things and magical things and sparkly things and all of that stuff, unicorns and whatnot. It all should stay in the real realm. And yes, I'm challenging what all the authorities say and all the people who have studied it very hard and all of that. You could make the same argument 200 years ago when they all believed in, really silly stories and silly Bibles. I mean, really a nonsensical narrative that anybody should just start reading it and say, what? I'm supposed to believe this? This is the best you can do in terms of giving me a theory of what it is to be alive? Is this mush? You know, just so bad. Silly hats. I mean, it's just terrible. That they fell for that garbage, especially when they knew there were a bunch of other people just across the ocean who had a whole different silly bunch of gods and things to believe in that were just wacky and nonsensical, and they could see that that was rubbish. Well, anyway, so the fallibility of humans is just a fact. And the fact that they can believe insanely silly nonsense and still function, okay? That, they can still invent levers and, make wagons and do different things and progress in their life and have a civilization and all that stuff. Yes, you can do it with a bunch of wrong ideas, but it's better if you do it with right ideas. Good theory, not bad theory. So all of physics is pretty much bad theory. I mean, the bent space, the quantum wooey phantasmagorical ESP particle, the whole, just too silly. It's just not a very rational story. A big space is somehow different than little space. All these things just don't go anywhere. They're just not logical, not sensible, not reasonable theory. And I would argue that you can put all the facts together and you can recognize, how to balance them, take which ones too seriously, which ones are really good facts, which ones are kind of crappy, and you can, make a model of reality that doesn't need to have any of this mush in it, this incomprehensible, bent nothings, thingies, and virtual things, and whatever. So anyway, but how to have the conversation? How do you even start the conversation where, oh yes, I'm telling you, that a lot of the stuff you believe is just garbage. It's just not very useful. So I would start by trying to explain there's one universe, okay? I mean, as much as it looks from our perspective like there's a whole bunch of different universes based on how big something is, there's just one place. There's a place, this empty stuff that has these three dimensions in it, okay? And this nothing, nothing. And then there's little somethings that have a position in that space. So, this is not new. Lots of theory, okay, recognize this Cartesian, whatever you want to call it, kind of way of perceiving reality. That we can move forward and back and up and down and left and right and, kind of get this idea of a spatial dimension. And, because we do have all of this advanced science, we can kind of know that we're on a planet, okay, and that the planet is covered in this atmosphere of matter, and so we're not in empty space, we're in a place that's full of a lot of other material things. So we're not living exactly in the universe as the little bits are. We're living in a big, complex place full of the other stuff, the not empty space. And so I would argue that we've also kind of been able to pick at it a little bit and figure out that the empty space basically just contains these little bits. We call them electrons and protons, and we've given them a some we've identified them with something. This one's the opposite of this one. It's a plus and a minus in terms of it has a feature. Now, I don't want to get to the feature because that'll just confuse you. But the idea is these things move around, okay, in space and around each other, so to speak. They have an orientation, let's just say, with each other. And, that we have the idea that if you put a few of these things together, in any whatever arrangement, that you create something, that we're going to call an atom, So an atom is basically stuff, okay, smaller stuff inside a small little package, and then the atoms can combine, and that creates compounds and all of that. So, but we don't want to go that far yet. So we just want to deal with these little bits and understand that that's all there is. This is the smaller universe, and this is what's in it. It's just bits, clumps of stuff we call matter. And then there's this stuff we know of as force, which is the light rays that are constantly flying all over the place, the radiation that we can control, the cell phone, Wi-Fi and microwaves that we send flying all over the place, the radio signals, all this other stuff flying all over the place, and all of it goes one speed, the speed of force. It's these little things are what just mess up people's perception, is they think that light is special when light's not special. There's forces, and all the forces move the same speed. So everything that's one of these invisible things going really fast, they're all doing the same thing. They're all moving the speed of force. Okay, so it should be an F for the speed of force, or SF or something. But yeah, all of that stuff is moving a speed, and we know that it does a basic thing, which is it hits stuff. It travels from point A to point B, and it hits this matter stuff and moves it, and it doesn't really hit itself. So I can't just crash a little piece of the force. Okay, I can't crash the force into the force and make something new happen. Okay, it just doesn't happen. And that could be for two reasons, which I've sort of explained. But the basic idea is there, in theory, there's no changing the universe by just having a single element bang into a single element, because if it bangs in and reflects, it's going to look exactly the same as if it never hit each other. The universe is going to look the same way. Stuff going this way, stuff going that way. It's just not going to change anything. And so to change something, you have to have more elements in play, and I'll get to that. But the thing to really understand is that at the fundamental level, there's only one thing happening. Now, there's really two things happening, but at the fundamental level, there's just this first thing. It's really the first thing to understand, is that this force stuff, moving the speed of light, is really just little clumps of momentum. So it's like little rocks or little bullets, and it's speeding around, and it just never, it has a constant, perpetual energy. Now, that might be hard to conceive. Like, how does something have perpetual energy? But it's just a fact, so you just have to deal with the fact that it just doesn't stop. So for whatever reason, it's hostile to existence in any place. It just can't be in a place. It just has to be pushed out of that place and go to the next place, and it goes in a straight line. For whatever its rules are. It could be shaped, and that means the shape is saying it has to go one way, but it doesn't really matter. The point is, it just goes in one direction, and it just goes in that direction at the speed of light when it's in this empty space. And the catch is, that you can have it in different arrangements. So I guess I have to do that first. So this stuff travels through space, And it's just constantly, so let's take this other one out. Just think electrons, protons. The same rules apply. There's just a subtle little difference that we'll get to later. Okay, so there's this stuff flying through the universe. And so you could say, see, there's a piece here and there's a piece here. And I'm just going to use the arrows to indicate it's got a direction. I could have a piece way over here. And so this stuff is flying through the universe. And everything is constantly being bombarded with it, essentially, in one form or another. So you can understand if this matter bit, okay, basically there's really simple rules. So this force is constantly hitting it, so you can get that idea. And I could say that the force just bounces off, but it doesn't really just bounce off, okay? And it doesn't really stick. It doesn't. You have to understand it a little more complexly, but it's not very complex. So you can handle this. So the idea is this has all the momentum. The point is this doesn't do anything. It has no will. It has no construction that says someday I'm going to be president of the United States. It has no ambitions. It doesn't desire to do anything. It doesn't have any legs or arms. It doesn't have any way to move or do anything. It's just sitting in the space, the matter. It's dead. It's just dead. Okay? It's a little bubble. And this stuff is the stuff that's moving. Okay? And there's a lot of it. And the whole universe is full of it. And it never dies. That's the key. It just never goes away. You can't, but you can occupy it for a while. So the idea would be as this stuff hits it, let's say this one actually hits it, and what's going to happen is this thing was going the speed of light, but now that it's hit this piece of matter, now it's got to push the matter. Okay, so it's stuck behind a piece of matter essentially, and it's going to move the matter at a much slower speed. So this is going to go much less than the speed of light, something much less. And until an event happens, that's what's going to happen. This is just going to push this along. Now this stuff there's so much of it, it's just flying all over the place. So what's going to happen, especially when you're moving into it, right? See, if this was moving, it means it's going to hit more of the stuff coming from this direction, right? It's going to hit it sooner than it would have. So it's going to be kind of plowing into more energy because now it's moving in a direction. And so what's going to happen is another one of these little bits, let's just say this one now is going to hit here. And what's going to happen is this one and this one, these two bits of momentum are now going to be able to interact with each other in a meaningful way. Unlike, just crashing into each other. Well, in this case, it's going to be just like crashing into each other in the sense that this is going to reflect because this is moving, and this is going to reflect because it's hitting. Something hit it. So this is the equal and opposite reaction, the kind of Newtonian mechanics. And so both of these things are now not connected to the object. And so now the object doesn't move at all again. It's stopped because nothing's pushing it. Right? The pusher left this way and this pusher left this way, so there's nothing to push it. Alright, so it just stops again and then waits for the next one. Now the catch is that you can send a few of these things in this direction, through matter interacting with matter. This is what can happen. And so then you can have more than one hit it. And so then it has one or two piled up. And so now it's going faster. So let's say if one's there, it'll go 1/10 of the speed of light. And then if two of them are on there, then it's 20% the speed of light, and so on and so on. Now if something hits it from this opposite direction, because now it got a little extra boost this way, so now it's moving faster this way, so now it's even more likely to hit stuff. Now if it hits it, it's going to reflect, okay, and it's going to lose one of these, but it's still going to be moving. So it'll keep moving because it's only going to reflect the extra bit. It's still got a bit here, so it'll keep going. And so this is basically the idea of a gamma ray or something like that, pushing an electron or something like that. And that would be giving it its momentum. It's not moving because it wants to move. It's moving because it's being forced to move. So every time these electrons are going somewhere, there has to be a bunch of this force, energy, behind it. There has to be a bunch of it pushing it, or it's just not going to go very far. Can't go very far unless it's got energy behind it to fuel it. So no matter moves without it being pushed. So the simple universe isn't bent space. There's no bent anything that's controlling it. There's no, there's real forces. And the force bits, the bits of force, have to actually interact with a piece of matter. And there has to be an actual, imbalance in the amount of this stuff. I could use fish as an analogy or something else. They have to be real things moving and banging into things for things to go anywhere. The matter doesn't go anywhere unless the force is there. The force has to have done it. The force has to push it. The force has to impose itself on it. Now, in this process, you may be able to understand that when matter is behind, when this force is behind a piece of matter pushing it, that it's not going the speed of light anymore. So in a sense, it should be way over here by now, right? It's been sitting here pushing this piece of matter. Well, it should be way up here. All these little bits of force should be way over here somewhere. Whoops. And they're not. So some other place in the universe is feeling less force because the force that would have been hitting them is stuck pushing a piece of matter. And this creates, kind of an obvious thing where that energy is now less energetic in a way. It's not moving the speed of light anymore. So it's definitely, if you understand that energy is how fast you're going, times how much mass you have, if you kind of understand that simple principle, then this stuff has to have lost energy because it's not going the speed of light anymore. So if I was to measure its velocity over time would be how much distance it travels. That's how I would tell, in a certain amount of time. Well, in a certain amount of time, these little bits aren't moving the speed of light anymore, so their velocity is less. Their velocity has gone down, and so therefore their momentum has to go down. Their real energy in the universe, their real impact in the universe has been in some way consumed. And that's what we call the origin of the thing called gravity. Gravity is created because these little bits that make up stuff, you have atoms, you have compounds, you have cells, billions of cells. Well, just imagine each cell made out of 10,000 atoms or 400,000 atoms or 1,000,000 atoms. So it's a billion kind of thing happening where, you have an awful lot of these little tiny bits inside of you, and all of them are doing this. They're consuming the energy of the universe by moving your electron from here, and then it moves it over here, and then it moves it back over here, and then it moves it over here, and then it moves over here, and then it moves over here, and then it's just moving it in all kinds of directions. So it loses a little energy that way, it loses a little this way, it loses a little this way, it loses a little. So it's losing it in all directions just because the electron happens to be doing this. It's all it takes to consume energy in the universe is just for something to do this, because now it's consuming energy in all of these directions because there's stuff pushing this way, not going the speed of light, losing a little bit of momentum. And it's a little bit, right? It's not a lot, it's just a little bit each time an electron moves. There's a little tiny bit of energy consumed out of the universe. All right, I'll start over. Sorry, I hate to be patronizing and have to make this juvenile, but apparently that's what I'm being forced to do it because no one wants to have the conversation. Nobody can have it in some sort of reasonable way where they don't just have to premise everything with some sort of silly insult. They can't really just argue the facts, at all. But anyway. All right, so now you can sort of understand that if you do have something like the Earth, and we understand, let's forget about the atoms, let's forget about the compounds, let's forget about the people, the trees, let's just understand it's a bunch of little electrons and protons. That's what it really is. That's the stuff really in the empty space, right? Inside the atom is a bunch of empty space, right? So I'm drawing the atom as a circle, right? It's not even a circle. No, it's an electron here, maybe an electron here, here. Another one there, and then the nucleus of protons in here. Something like that. And I would argue these are all magnetic, but I'll get to another, they're not spinning around and orbiting and doing all that crap. but they are jiggling. They are getting moved around constantly. They're in this field of force, and the forces are moving them around. And because of the rules of reflection, as I just explained, basically it's always going to be a reflection. The electrons are bouncing energy back and forth between each other constantly. And that's why you can create pressure inside of an atom, is because for an electron to move one way, it has to increase the pressure between the other objects. It has to get closer to things it is repelled by. So that's probably not a very challenging or offensive statement to make, is that electrons repel each other, based on this simple argument that if they're reflecting energy at each other, the energy always carries a momentum in the direction the force is moving. So, whatever you're reflecting to something it's going to feel it as momentum. Now, the catch is that protons and electrons have an inverse relationship, but I'll get to that later. All right, so just that's so the Earth is just made out of a bunch of electrons and protons. I mean, indescribable number of them. And what's happening is all the time these little bits are in fact moving around, and they're moving their positions, and then whole atoms are turning and spinning, and the whole center of the Earth is hot as heck. Okay, it's really hot in the middle of the Earth because of exactly this process of moving little bits around. That's heat, and heat is really just energy. It's just a different word for it because we see it in a certain form, but elementally it's the same thing. I mean, a radio wave is actually heat, and all of it's heat, and we can call it something else, but it's really just movement of these little bits, and energy that can cause the movement of little bits. It's momentum in this speed of light form, and that's what heat is a byproduct of. Is this stuff crashes into an electron and proton, it moves it. Well, if it moves the electrons and protons, it can also move the whole atom, and it can move the whole compound, and but it's all heat. Okay, you don't have to move an atom to have heat. All you have to do is move the parts inside, because that'll eventually probably lead to movement in the entire atom. But anyway, so you can understand that this thing is just, there's a bunch of stuff moving in every direction. So every direction there is energy being consumed. So a certain amount of energy goes into the Earth, in the sense that this external world is throwing crap at it from all directions constantly, and a little bit less comes back out. And that's the simple reason why material objects create what we call gravity. Gravity doesn't have anything to do with like, okay, I'm here and I'm going to communicate with you and we're going to make gravity. Two things don't make gravity. The single object is making the gravity. Just by existing in the universe, even if nothing else, no other matter exists in the universe, if all you had in the universe was one planet, okay, it would still be making gravity, even though there was nothing else to measure its gravity, to fall into it. The fact is it would exist because there's less energy coming out and more energy going in. And if you're sitting here in that circumstance where more stuff is going this way, okay, than is going this way, right? And we got two things going this way and you got three things going this way. Well, your bit of matter is going to end up over time being pushed in this direction. This is going to hit, and then there's going to be a reflection. All that stuff's going to happen. You're going to move, and then you're going to stop, and then you're going to move, and then you're going to move faster, and then you're going to slow down. But anyway, you're going to herky-jerky your way right into the Earth, because over time, there's more energy going one way than going the opposite way. So over time, your dumb matter, your matter that doesn't have any ambition or will of its own, is just going to keep getting pushed into the Earth. So it's a nuclear force, gravity. Gravity is hitting all of your little bits, and it's pushing them all the same because it's really dense, okay? And even when it doesn't, let's just say that you had a whole bunch of matter and then you had the force out here. It's the same difference because, see, there's force between all of these little electrons. And so when you bang into this one, you're really pushing this one closer to this one, and then this stuff bounces even more, and that creates pressure, and so this one moves, and then this bounces, and this one moves a little bit into this one, that creates extra pressure, and so this one has to move. So it's just conveys the pressure through the atoms. But the fact is, all this is happening at the speed of light, essentially, and so you don't feel gravity. So no matter how much gravity I put you in, you never really feel it. Unless you go to some extreme case, where, the gravity at 3 feet is different than the gravity at 2 feet or something. It'd have to be an insane amount of gravity that you're falling in for your body to in any way feel any differential. So for all common circumstances of gravity, it doesn't matter whether it's 10 meters per second or 100 or 1,000 meters per second, you wouldn't feel any of them. They would move you so clean, like your feet would be going just as fast as your head. They'd all be pushed with an equal amount of pressure, that you wouldn't feel it because no part of you is being distorted. So you feel a force when the force is affecting you disproportionately. So what you feel is when you're on the earth and you hit the earth, right? Say you were falling in gravity, you wouldn't feel a thing. But as soon as you hit the earth, well, now the force can't go into all your little, you can't get to all your little bits. So it has to push the bit through your feet, okay? And then it has to push it through the rest of your body, and it pushes it through very unevenly. So that's why you feel gravity when you hit something, is because you're really feeling the something you hit. And the fact is, that force doesn't get into you evenly. It moves your feet faster than it moves your head. It moves them disproportionately. Your torso and your skeletons, that moves, your bones move, and the rest of your guts aren't moving yet. So it's all very uneven, and that's why you feel it. So the only time you feel a force, the forces, is when the force is really matter moving, and matter's hitting you, and matter's pushing you. That's when you'll feel it. But you won't feel it when the actual little bits are doing the job, because the little bits do it very efficiently. They go through you really efficiently, so you don't feel anything. Now that's really not important to this whole subject, but it's a context to understand how regular physics hasn't even talked about or understood that simple fact. This mouse is in my face. And that's a huge fact, in terms of when they're explaining things to you and trying to give you the gooey, what do you feel, so they make it sound like being in an elevator is the same as falling in gravity on Earth or some other thing, and they're really not comparable, only in the sense that clearly the forces are affecting you very differently, and gravity isn't the Earth pushing you back up. Gravity's the thing pushing you into the earth, and you never felt the thing. You never felt being pushed into the earth. The only thing you're feeling is the earth pushing back, which is a second force, which is another force. It's not gravity that you feel. It's the earth saying you can't go in here. And so they can't even explain that one, properly. And so another reason not to have too much confidence in the physics they're telling you all this time. They've had thousands of years to figure out just that simple little truth. Okay, that means kind of just a simplistic little truth, that you don't feel gravity, you feel the earth pushing back. It's a very simple little truth. And they don't tell you that little truth, right? Just like they don't talk much about there only being one universe. That there is no cosmos and these different places you can go. there's one pile of empty space, and then there's all the little stuff in the universe is interacting in the same space with the same rules, and the only universe is the little universe. Everything that happens with the little things first. They do it before you do it, okay? You're not dragging them along. They're pushing you along, okay? So it always happens there first. Whether your muscles are moving or some other thing, there's lots of stuff going on that happens, in universal time. It's milliseconds, but it's happened there first, okay? It happened on the little universe happened first. They did it first. the mechanism that caused it was there first. You could see it there. You can't see it, the idea even in your head. Okay, it was an arrangement of these little bits of matter moved around before it was an idea in your head. Right, so that's what's controlling everything, is just the little stuff in the universe, and the fact that it can be arranged, and these simple little differences can be these simple little functions can be turned into a lot of diversity. Just like you can turn 4 little pieces, 4 letters of the alphabet, just 4 letters make all of the DNA code. It's just made out of 4 letters, the arrangement of 4 letters. So you can get that, you can do a lot with just 4 things, rearranging them and changing positions and putting, all the L's over here and all the W's over here. You can fundamentally make the universe look very imbalanced, even though it's made out of something very balanced, which is just a certain amount of these things, the matter bits, all right, and a certain amount of these little energy bits, and that's all the universe is made out of. It has a certain amount of these things moving the speed of light, it has a certain amount of this stuff not moving, the electrons and the protons, and the whole universe is just happened because you mixed these things with these things, and it takes time for it to mix, and it's just mixing by really simple rules, just simple rules, reflection rules. All right, so do I have to go there now? So let's go there now. Okay, so as pointed out, there's, you can't see any difference in the universe if all I have is stuff going this way, and stuff going, say, this way. All right, and those things collide, and what leaves goes this way, and this leaves going that way. Well, I can't change the, even if this went this way, even if it turned this way, or if it, if they reflect straight back. No matter what I do, I can't make the universe different. I can only make, I'll end up with the same results. But if I have a simple change, if the two things are in some way different, well, then I'm going to see the difference, and most clearly I'll see it this way. So if there's 2 different things hitting each other, well, then I can, then this is going to happen. Okay, and this isn't going to be the same as missing now. Missing means there's a blue thing going this way and there's a white thing going that way. So missing and hitting won't look the same anymore. The universe won't look like the same place. It'll be different. And that's what matter is a conduit for. So matter allows there to be a circumstance where something, say, goes in this way and it comes out this way. All right. So it creates the opportunity, or it comes out, in or out of the object. It changes what dimension the momentum is moving in. So momentum going this way was going to hit this over here. Now it's never going to hit this over here, because now it's gone a completely different direction. So it's not just going to be delayed in getting here. It's not going to get here, okay, because it got diverted. So that's kind of a simple mechanism. And this even simpler mechanism would be understanding that it does this without creating any momentum in this object. So this object doesn't move. So when a certain thing hits, okay, you could say it just goes through and turns. And if the other thing hits, then it does that, eventual reflection thing. Okay, and it causes this to move. So you have just 2 rules. One rule, you push the object. The other rule, the energy is just diverted. So that's about it. So you have 2 rules that now change what's going to happen in the universe, because now you can redirect force. You can change how it's moving, and that's going to make it. That's giving you the 4 letters. That's giving you a feature, okay, that enables there to be a lot more complexity in the universe. Now I can create laser beams, and I can create gamma rays, and I can create other things. All right, so the other thing the other big picture kind of idea. Yeah, before we get to this, so that's the nature. I'm just glancing at the subject of charge and just explaining that the universe is really two universes. One universe is the electrons and the electron force, right? So that's just simply electrons and the force bits. And the other universe is protons and the proton force. And the only way those two universes are connected is that when a proton force hits an electron, it just does that deflection thing. And when an electron force hits a proton, it just does the deflection thing. So the only way the two are connected is that the force from that's in one universe, the proton and this momentum, is just that simple little thing. It just changes the direction of the force. So it's all just this force moves these objects, this force moves those objects, and this one connection between those two on top of each other universes is that when this blue force, when the white force hits the blue object, it just turns, and when the blue force hits the white object, it turns. And which way it turns depends on whether it's moving or not moving, because it's really the turn is really going to be an exchange. Okay, so inside the object it'll be like this thing is coming this way and the blue force came in this way, and there's going to be that little interaction where the white force is also going to be changed in this direction. So the matter is just a conduit for an exchange between the two forces, the two universes interacting. But anyway, that's getting more complicated than I want to get, because I want to get to the thing I have gone over before, which makes it understandable how moving things changes things. So when you move the thing, I need some I need a more fancy studio. So anybody who's really rich out there, anybody filthy rich, come on. The universe needs, everybody in the world needs the truth. Come on, finance the truth. You'll be a hero. Anyway, so what was I getting to? All right, so this thing is a piece of matter, right? And so what I'm saying is you can hit it with force and you can get it to move. And if it's moving, what's it going to do as it's moving? Well, again, it's moving into stuff. So if I have three things moving here, coming towards it, right, spaced like this, well, it's going to move into them and it's going to do this reflection thing. So it's going to reflect this one at this location, but it's going to move quickly into this one, so it's going to hit it before it would have hit it if it was a solid object. If it's a solid object, you can see the reflections will just reflect the same pattern. So this one hit first, this one will be the furthest away, this one will reflect second, so it'll be the second furthest, and this will be the furthest, So it'll reflect the pattern right back to the universe exactly how it was if it's stationary. But if it's moving, what's it going to do is it's going to reflect it in a compressed amount of space, and so now when it's the reflection is going to be in a much smaller amount of space. So if you have this much space for the pattern, now the pattern is going to be in this much space. So I can't really draw it right, but you get the idea. I think you can get the idea. And the opposite will happen if it's going away. If it's going away, then it's going to spread the distance out. The distance between this and this is going to be turned into this, right? So now you're capable, by just moving matter, of completely changing the frequency, the density of the force. So there's this consistent amount in the whole universe, you could argue, of force hitting stuff. And by moving, you make compressions, you make consolidations of that force, and you put a lot of force in a small amount of space, and then you end up with this whole idea of photons and radiation. So I could take a a red photon, it has a certain frequency. If I bang it into an electron that's moving towards it, you can sort of understand that I can turn that into a blue photon, okay? Because I'm going to reflect those bits now in a smaller package. All right, so I'm going to take something with a lower frequency and make it a higher frequency by eliminating some of the space between, by just moving electrons. So as the electrons herky-jerky around,
what they're doing is by moving, they're moving into an opposite force, and they're going to cause the contraction of that force. And by moving away, by moving away from the force that actually did push them, you can sort of understand those reflections are going to end up being spaced wider, because they've been collected and now they're going to be reflected at a rate. So it's going to be an opposite effect you're having when you're moving away from something versus moving towards something. But to move away, you actually have to be pushed. So that's a whole another part of this subject. And so if you're pushed by a whole sequence, of a lot of energy behind you, then you're just going to reflect that energy back again in the opposite direction as you plow into more force. But it depends on what you're plowing into, and that'll change what you're reflecting. So what's coming towards me, I'll change by moving into it. And then what was coming towards me from the back, I'll also change by moving away from it. And that's the simple mechanism that's controlling everything in the universe. I mean, that's as simple as, that's really simple. This idea that you have matter, it's in a field that's constantly moving towards it, constantly hitting it from all directions. And every time it moves into that field, it pushes the energy. It reflects it sooner. It compresses the space that whatever pattern might be in that field, that energy, I'm going to change that pattern. And I'm doing the same thing in the opposite. And as I said, if I move this quick enough, you can understand it really simply, right? If I move it at the speed of light, all the photons between my hand and the point I stop moving at the speed of light, all of them will be reflected when I stop. All of them are in the same location. They're all getting stuck to each other and being collected. And now they'll be all in a tiny amount of space. And the opposite happens when I'm moving quickly away. You could understand that nothing can reflect off me. I'm moving as fast as all the stuff is moving. None of it can ever catch me. None of it can ever bounce off of me. And now I'm completely invisible. I don't exist as a material object from your perspective. If I'm moving away from you fast enough, I don't exist. You can't know of my existence. Yeah, so that's it's a starting point. How to. But the point is that all you need is this simple mechanics. All you need is an understanding that the fundamental elements of the universe are just the idea of electrons and protons, the force, which just has this, like I said, it is just as simple as just saying it's red and it's blue. Or it's white and it's blue. It's that simple. You can just understand the force is two kinds of colors to complement the fact that there's two kinds of elemental charges. Okay, so you have the electrons and you have the protons. They have a force that gives them momentum, and if the opposite force hits, it does that little silly. Oh, that's it. It just takes a turn. That's all. Nothing terribly complicated. And that's all you need. This is all you need for a mechanism to explain everything we see in the universe. It really is that simple. It's just exchanges of momentum, and what you're doing is changing what something is by changing its pattern. So just by moving electrons and protons in the universe, you change the reflections, the patterns, where they're going, whether they're going this way or whether they're going this way. And you change them whether the pattern is tight, like a gamma ray, or whether it's wide, like a radio wave. All of that is changed just by moving electrons and protons at a significant speed. If you move them really slowly, they don't have much of an effect on changing the pattern. So you have to move them relatively quickly for them to change the pattern. But you can understand they're really tiny, so quickly isn't much distance. All right. So, that's probably enough of a starter. Look, one universe, small universe, just two kinds of force, two kinds of matter, and two kinds of interactions. And you just don't need all of this other mumbo jumbo. This explains momentum. This explains F equals ma. This explains, it's all there. You can make it all out of these simple pieces. And you don't need any ESP particles, you don't need any, superpositions, you don't need any singularities. I mean, all these silly words for silly concepts. I mean, can you see somewhere in your brain where, oh yeah, the electron eats the proton and they both are in the same space? I mean, it just doesn't make any sense. The matter can't be in the same three-dimensional space. There's locations in space. They can't occupy the same space. They're real things. Real things can't do that. I mean, they're made-up stuff you really just don't need to make sense of it all. You really don't. You can understand that, like the planet Earth, for example, it has a bunch of atoms. Now you kind of know, some of this stuff we figured out is, the stuff is really small, the electrons and protons, but the atom is kind of big. So it's got very little density, very, very little. Lots of empty space in the atom, not too much space occupied by actual physical stuff. So you can understand that there's lots of room to compress that. Now, you don't have to compress it into them being on top of each other and being in the same space. You don't have to make it that small. To understand that all you have to do is compress it quite a bit, get this, like the nucleus, for example, where the protons are really close to each other, make it very compact, and if you're still jiggling it, well, then you're still going to have gravity, right? But that's the question. If you make it really small, how can it jiggle? How could it make gravity, right? So you can kind of defeat the logic of their theory by just understanding that, yes, it makes sense. Jiggling things uses energy. By using the energy jiggling something, moving something, I'm creating an energy disproportion. The energy that's jiggling it is using something up. Okay, it's consuming something. So there's that deficit's real, and that's, it's just such an obvious explanation for gravity versus bent space, whatever that is. It doesn't make any sense. All right. So one version of attempting the conversation. I mean, there's a lot to go, a lot further to go here. It's physics. You can't do it in, 10 minutes. All the interactions that are possible and to detail them. But, this is the evolution theory versus religion as a parallel. I'm just saying this is the simple answer that doesn't contain any of this duality crap and all of the phantasmagorically not really real kind of things they keep talking about in physics. All of these spooky actions at a distance. There's no spooky action here. The force has to go somewhere. It has to hit something. A real event has to take place for something to happen. Nothing moves because it senses something else with magic sensing powers. It has to sense it by throwing shit at it and having it throw shit back. And that's the only way things can interact with each other, is they have to throw real rocks at each other. They can't just, I know you're there and I will move this way. I can't even move this way unless they hit me with something that moves me that way. That's how real the real universe is. You have to really hit something. You can't just say I hit you or yell words at something. You have to actually throw something. You have to reflect it. You have to real events have to take place. There's just there's no notion of charge where something just goes by it and says, I made this wiggle by just passing. No, there's none of that. You have to be throwing force. You have to be doing something to each other to be able to move each other. You can't just magically move anything. You have to use a force. You have to use the little rocks. You have to fire the bullets. You have to use and manipulate the energy to be able to cause something to happen, for something to move. You have to throw energy at it. Okay. As stated, I'm attempting to reason with you. I'm getting very little reasonable anything back, and it's just amazing that nobody wants to have this conversation. Nobody wants to sit there and argue these simple premises and say why they're wrong, why it can't be, why it has to be some other complex way. Nothing. Just nothing. Yeah. So, till the next time, and such. I think it's enough. I will declare it so. It's enough for today. Okay. So, till the next time and such. Been DraftScience video presentation.